Welcome to pre-calculus video for skill number 38. I can find the y-intercept and x-intercepts of a quadratic equation. And in the photo below we have a strap here, and we're showing that a 45-degree angle is ideal for that strap. The trivia question is, what is the name of that strap on a backpack? Okay, so this skill should be fairly straightforward. We're talking about quadratics, which we've dealt with a little bit throughout the year, and a quadratic has a parabola shaped like something like this. Maybe it opens downward, but you can see that in this case the parabola has two x-intercepts, and if I kept going up here I would have one y-intercept. There's also the possibility of having a parabola that only touches at a single point, so that is one y-intercept and one x-intercept. So you got your x-intercept. It comes down, and you could say it touches it twice there if you wanted to, but more or less there's only the single x-intercept and then only the single y-intercept. And the final case would be a function, a parabola that is above the x-axis, or maybe it's below it and opens down. Both of those have no x-intercepts, but eventually, if we kept going up, we would eventually hit the y-axis and we'd have a y-intercept. And this video is focusing on finding those x and y-intercepts, or creating an equation if you know the x and y-intercepts. So let's take a look at the homework problems. So the first homework problems, we're going to start with the given information of what the x-intercept is and what the y-intercept is, and we need to create the equation for that. And it's actually pretty straightforward. You don't need a lot of room, so I haven't given you much. But the way we start this is your function will be y equals a times x minus your first x-intercept, and then times x minus your other x-intercept. So maybe we'll call this x-intercept 1 and x-intercept 2. And then we can figure out a after the fact. So in this case we have x-intercepts of 2 and negative 5. So we're going to write y equals a x minus 2 times x minus negative 5, which we could simplify to y equals a times x minus 2 times x plus 5. Now we need to figure out what is our value of a, and in order to do that we have to look at our y-intercept. And our y-intercept is 3, and that occurs when we have an x value of 0. So if we were to substitute in 0, 3 into our equation, we could find out what a is. So let's put 3 in for y. We don't know what a is. And then 0 in for x. 0 minus 2, 0 plus 5, and we get 3 is equal to negative 10a. From there we can conclude that negative 3/10 is equal to a. So to write our equation, our final answer, we have y is negative 3/10 times x minus 2 times x plus 5. And that would be the equation in factored form. The instructions ask us to first write it in factored form and then to also write it in standard form. So I'm going to move over here to the left. To write this in standard form, the first thing I will want to do is FOIL these out, or to distribute this out. So I have y is equal to negative 3/10 times x squared plus 5x minus 2x minus 10. And you can see I got x squared plus 5x minus 2x minus 10. I can combine like terms. The 5x and the negative 2x combine into 3x. And then finally I want to distribute the 3/10 into the function to arrive at my final answer. Y is negative 3x squared over 10 minus 9x over 10 plus 30 over 10, or just plus 3. There we go. Standard form. Alright, so I graphed this on the calculator to check my work, and 1, 2, 3, 4, 5. We have a x-intercept at -5 and at 2, and then a y-intercept at 3. So it looks like my standard form works out. I'm going to move on to problem number 22, which is of a similar vein. We start by writing y equals a times x minus your first intercept times x minus your second intercept. And so then what we need to do is we need to account for the y-intercept of 4. So we're going to plug in this coordinate to the equation, and we'll get 4 is equal to some value a times 0 minus 1 times 0 minus 3, and that gives me 4 is equal to 3a, or a is 4/3. Therefore, our factored form is y is 4/3 times x minus one intercept, x minus the other intercept. So there's my factored form. If I want to convert it to standard form, I'll start by distributing the x minus 1 times x minus 3, and I will get y is equal to 4/3 times x squared minus 4x plus 3, and I multiply the 4/3 through to get my final answer. Y is equal to 4/3 x squared minus 16/3 x plus 4. And there we go, our final answer. And a nice simple check we can do is we can see that the c coordinate of our standard form matches with our y-intercept, so those two should always match. Let's move to the next problem type, and they're not in the textbook, so you won't find answer keys for them. Just kind of follow along the example. I feel like they're pretty straightforward problems. So it says, for each of the following quadratic functions, find the x-intercept and the y-intercept. So the first thing I'm going to do is I'm going to FOIL it out. I'm going to combine my two pieces, and then there will be no further calculations needed. So if I take my -3, and then I'm going to multiply x squared plus 5x minus x is plus 4x minus 5, and then finally multiply the -3 in. We'll get -3x squared minus 12x plus 15. And at this point we have all of the information we need. It says find the x-intercepts. So the x-intercepts occur where the factor equals 0. So we have two x-intercepts. We have an x-intercept at 1, 0, and we have an x-intercept at -5, 0. And then finally we have a y-intercept at 0, 15. And that's pulled from this number. If we wanted to, we could plug 0 into the equation to find our y-intercept. So we'd have -3 times -1, which is positive 3, times 5, which is positive 15. So that might be a faster way where you can find the y-intercept without even distributing the factors through one another. I will do that with example D so that you can see the two things, the two different ways to do it. To find our x-intercept, we either have x minus 1 equals 0. So if we solve for that, we get x equals 1. So we have an x-intercept at 1 comma 0. And then we also have an x-intercept where this factor equals 0. So that's at negative 5 halves. So we get an x-intercept at negative 5 halves, comma 0. And then finally, to find the y-intercept, we replace x's with zeros, and we get 4 times negative 1 times 5. So negative 4 times 5 is negative 20. So we have a y-intercept at 0 comma negative 20. There you go. 2 x-intercepts and a y-intercept.
Wow.
These ones get a little bit trickier because they're not already in factored form, but when it's not in factored form, we can very quickly find the y-intercept. So we have a y-intercept at 0 comma negative 18. But to find the x-intercepts, we're going to need to factor it. So the first thing I do is I pull out the greatest common factor of all three terms, and that would be a 2. So we have 2x squared minus 7x minus 9. And then from there we're going to try to factor this problem. When we examine it and we start pairing up possible numbers, we realize there's no numbers that multiply to 9, or multiply to negative 9 and add up to negative 7. So we must turn to our quadratic formula to find the x-intercepts. And as a reminder, our quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we will plug those values in, and we get 7 plus or minus the square root of 49 minus 4 times 1 times negative 9 all over 2 times 1. If we simplify that out, we're going to get 7 plus or minus root 49 plus 36 is 85 over 2. So we have x-intercepts. Let's go off to the side here. X-intercepts of 7 plus root 85 over 2 and 7 minus root 85 over 2. So sometimes we get these irrational x-intercepts, and using a grapher we can trace them and get an approximate value, but using the quadratic formula we'll get the exact value. Let's see what we can turn out on H. Oops. Alright, on part H we got a function here where we might be able to factor it. We might try to factor it, and perhaps there's something, it would be kind of a challenge to figure out what the factors are, especially with this leading coefficient of 7. So I'm just going to jump right into using the quadratic formula and see what comes of that. So negative b is 31 plus or minus the square root of b squared minus 4ac all over 2a. And obviously we're going to need to use a calculator to see what is here in the radicand. So we get 31 plus or minus the square root of 1521 over 14. And the square root of 1521 is actually 39. So we have 31 plus or minus 39 all over 14. 31 plus 39 is going to be 70 over 14, and 31 minus 39 is going to be negative 8 over 14. So those are our two x-intercepts, both of which could be reduced if we wanted to. 70 over 14 is 5, so 5 comma 0, and negative 8 over 14 we get negative 4/7. And then finally, to find the y-intercept, that's the easy one. We just look at the c value. We have a y-intercept at 0 comma negative 20. I graph these on a calculator to verify, and it appears as though they are correct. So that's one of the best checks you can do, is to graph the equation on a calculator. Okay, let's move to the final problem. 5x squared minus x minus 18. If we do 5x, x, and probably a 2 and a 9 would multiply to 18. 5x times 2 is 10, 9x. That works out. Let's put a plus here and a minus there. And this does check out. So this is the factored form, and you can use whatever method you want to work at your factoring, but go ahead and take a shot at that and see if you come to the same conclusion as me. Alright, so if we take these two things and set them equal to 0, we're going to find the x-intercepts. So setting the left one equal to 0, we get an x-intercept of 9/5 comma 0, and setting the right one equal to 0, we get an x-intercept of negative 2 comma 0. And finally, the y-intercept again is the easy one. We're just going to take that value, and that's our y-intercept. So we have a y-intercept at 0 comma negative 18. Alright, thank you for watching. Hopefully now you're a little more versed in finding x and y intercepts. Keep in mind, all polynomials, or rather even all functions, will have at most one y-intercept. So there's only one. And a quadratic will have 0, 1, or 2 x-intercepts, but never more than 2. The answer to the trivia question is this strap is called the load lifter strap. Thanks for watching.